Every time you unlock your phone, every time you ask an AI a question, every time you stream a movie, somewhere on Earth, a building wakes up. It doesn't have a famous name. Tourists never visit it. Most people drive past it without giving it a second glance. From the outside, it looks like an ordinary warehouse. No giant logo, no glass skyscraper, no flashing lights, just concrete walls, steel fences, and enough security to make you wonder what's hiding inside. But behind those walls sits one of the most valuable businesses in the modern economy, not because it stores gold, not because it manufactures cars, but because it manufactures something even more valuable: computation. Every photo you've ever backed up, every online payment you've ever made, every cloud document, every Netflix binge, every Instagram scroll, every ChatGPT conversation. At some point, they all pass through a building very much like this one. And those buildings are becoming some of the most expensive pieces of real estate on the planet. Some cost hundreds of millions of dollars to build. Others cost several billion. Yet the building itself isn't the biggest expense. In fact, there's one cost so enormous that it determines where these facilities can even exist. We'll come back to that, because once you understand why investors are racing to build these digital factories, you'll never think about the cloud the same way again. Ask someone where the cloud is, and they'll probably point upward. The name itself makes it sound weightless, invisible, almost magical. But the cloud isn't floating above us, it's sitting on the ground, inside thousands of buildings spread across the world. Every email, every website, every banking transaction, every online game, every AI prompt, they're all processed by physical computers living inside physical rooms. Imagine walking into one of these facilities. The first thing you notice isn't the computers. It's the sound. Thousands of cooling fans blend into one continuous roar. The air feels colder than most office buildings. Bright rows of cabinets stretch so far they almost disappear into the distance. Each cabinet contains servers. Each server performs millions of calculations every second. Together, they're handling millions of people at the exact same moment. While you're watching this documentary, someone is uploading wedding photos in California. Someone is transferring money in London. Someone is booking a flight in Tokyo. Someone is asking an AI to write code in Berlin. And somewhere inside this building, those requests are arriving every fraction of a second. The internet isn't one giant computer. It's a network of digital factories working together around the clock. Factories that never close, never sleep, never stop producing. Because the moment they do, parts of the internet disappear with them. But if these buildings are so important, why don't we hear more about them? Because unlike airports, ports, or skyscrapers, their greatest strength is being invisible. And that's exactly what makes their business so fascinating. Imagine someone offered you the chance to build a warehouse, not for products, not for people, but for information. At first, it doesn't sound like an exciting investment. Warehouses don't usually become billion-dollar businesses. Yet data centers have quietly become one of the hottest assets in the world. Governments compete to attract them. Investment funds spend billions buying them. Pension funds invest in them for decades. Real estate companies are transforming themselves just to own more of them. Why? Because once a customer moves into a data center, they rarely want to leave. Moving thousands of servers isn't like changing apartments. It's expensive. It's risky. It can interrupt businesses serving millions of customers. That creates something investors love: predictable, long-term income. But stable income alone doesn't explain today's gold rush. Something changed almost overnight. Artificial intelligence. Training modern AI systems requires enormous amounts of computing power, and computing power requires servers. Servers require buildings. Buildings require electricity. Lots of it. Suddenly, companies weren't just competing for land, they were competing for access to power. Entire regions that once seemed ordinary became incredibly valuable simply because enough electricity was available to support new data centers. In some places, developers have billions of dollars ready to invest. The land is available. The customers are waiting. But construction can't even begin, not because they're missing money, because they're missing electricity. And that completely changes the story. These aren't just technology companies anymore. They're becoming some of the largest industrial consumers of power on Earth. Which raises an even bigger question. If electricity is becoming more valuable than the building itself, how much does it actually cost to keep the internet alive? That's where the economics become truly astonishing. At first glance, a data center doesn't seem like much of a business. People don't walk in and buy anything. There are no shopping carts, no checkout counters, no products leaving on trucks. So where does the money come from? The answer is surprisingly simple. A data center sells something every modern company desperately needs: space, power, and trust. Imagine you're running a global company. You could spend hundreds of millions building your own facility. Or you could rent space inside one that's already operating. That's exactly what thousands of businesses choose to do. Instead of leasing office space, they lease digital space: a single cabinet, a private room, an entire floor, or in the case of companies like cloud providers, sometimes an entire building. But they're not just paying for square footage. They're paying for uninterrupted operation. Every server inside those walls must remain online. Every second, every minute, every hour, every day of the year. Because even a few minutes without service can create chaos. Imagine a bank suddenly losing access to customer accounts, an airline unable to process bookings, hospitals disconnected from patient records, or millions of people discovering their favorite apps have suddenly vanished. The building isn't simply storing computers. It's protecting entire businesses from disappearing. That's why customers sign contracts lasting years, sometimes even decades. Once thousands of servers are installed, moving them somewhere else isn't just expensive, it's risky. Every cable has to be disconnected, every machine transported, every system tested, and every mistake carries enormous consequences. For investors, that's almost the perfect customer. Long contracts, predictable income, high switching costs, very low turnover. It's one of the reasons data centers have become so attractive to long-term investors. But that's only one side of the equation, because keeping those promises costs an astonishing amount of money. Walk through a modern data center, and you'll notice something strange. The servers aren't actually the most impressive machines inside. They're surrounded by an entire ecosystem working just to keep them alive. Electricity enters the site through massive transmission lines. Before reaching a single server, it passes through transformers, switchgear, backup batteries, monitoring systems, power distribution units. Every step is duplicated, sometimes 3 times, because failure isn't an option. Then comes cooling. Computers create heat. Thousands of computers create an unbelievable amount of heat. Without cooling, temperatures would rise within minutes. Equipment would begin shutting down. Services would fail. Businesses would stop. So giant cooling plants work continuously behind the scenes. Cold air, chilled water, industrial pumps, massive pipes, precision sensors, thousands of tiny adjustments every second. It's less like cooling an office and more like operating a power station. Then there are backup generators, rows of enormous diesel engines waiting for a moment that everyone hopes never arrives. If the electrical grid fails, the batteries respond instantly. Within seconds, the generators roar to life. Most people never notice. Their movie keeps streaming. Their online meeting continues. Their AI conversation never pauses because the transition happened before they even realized anything had changed. That's the goal, not dramatic recovery, invisible continuity, which creates an interesting paradox. The better a data center performs, the less anyone knows it exists. Ask most people what the most expensive part of a data center is, and they'll probably say the building, or maybe the servers. Both seem like reasonable guesses, but over the life of the facility, neither is usually the biggest expense. Electricity is, and not by a small margin. Think about what's happening every second. Thousands of servers are processing information. Cooling systems are removing enormous amounts of heat. Networking equipment is moving data across continents. Security systems never switch off. Backup batteries stay fully charged. Monitoring software watches every circuit around the clock. Nothing sleeps, not even for a minute. Now multiply that by every hour, every day, every year. Suddenly, electricity isn't just another utility bill. It's the foundation of the entire business. Without reliable power, a billion-dollar facility becomes an empty shell. That's why developers often begin searching for electricity before they even search for land, because land can be purchased almost anywhere. Reliable high-capacity power cannot. Some of today's biggest projects aren't delayed because they lack investors or engineers or customers. They're waiting for something much simpler, enough electricity to exist, and that's transforming an unexpected industry: utility companies. For decades, electricity simply followed economic growth. Now, economic growth is following electricity, Entire regions are competing to expand their power grids. The internet isn't running out of ideas. It's running into the limits of physics. And that's only the beginning, because once artificial intelligence enters the picture, everything you've seen so far starts to look small. For years, the data center business followed a fairly predictable rhythm. More people used the internet, companies built more servers, developers built more facilities, demand grew steadily. Nothing too dramatic. Then artificial intelligence arrived almost overnight. The rules changed. An AI chatbot isn't like a search engine. A recommendation algorithm isn't like streaming a movie. Training and running modern AI models requires an entirely different level of computing power. Imagine replacing a fleet of delivery vans with thousands of freight trains. The destination might be the same, but the infrastructure required is completely different. Traditional servers were designed for everyday computing. AI demands specialized processors packed together by the thousands. These machines consume far more electricity. They generate far more heat, and they require entirely new cooling systems. Suddenly, facilities that looked cutting edge just a few years ago began reaching their limits, not because they ran out of space, because they ran out of power. The industry wasn't simply building larger data centers anymore. It was building a completely new generation, digital factories designed specifically for artificial intelligence, and whoever builds them first could help shape the next decade of the global economy. Think about your laptop. After running demanding software for a while, it becomes warm. Now, imagine thousands of computers working at maximum capacity, every second, every day. That heat has to go somewhere. For decades, large fans and carefully controlled airflow were enough. Cold air entered one side of the servers. Hot air left the other. Simple, reliable, effective, but AI has pushed those systems close to their limits. Today's processors can produce so much heat that air alone often isn't enough anymore. So the industry is returning to something surprisingly familiar. Water special cooling systems circulate liquid directly around high-performance equipment, carrying away enormous amounts of heat far more efficiently than air ever could. In some facilities, cooling has become almost as important as computing itself. Entire buildings are now designed around moving heat rather than moving data. It's a strange reality. The future of artificial intelligence may depend as much on plumbing as programming, and every improvement in cooling unlocks even more computing power, which means the race never really ends. Ask someone who owns the internet, and you'll probably hear the same answers. Google, Amazon, Microsoft, maybe Apple. They're certainly some of its biggest users. But the real picture is much more complicated. Imagine the airline industry. Airlines don't build every airport. Shipping companies don't own every port. Hotels don't manufacture every elevator. Instead, entire industries exist to provide the infrastructure everyone else depends on. The internet works the same way. Behind every cloud service is a network of specialized companies building and operating the digital real estate of the modern world. Some companies own enormous campuses and lease space to hundreds of customers. Others build facilities first, then rent entire buildings to cloud providers. Some investors never touch a single server. They simply own the property, collect long-term rental income, and let technology companies fill the rooms. It's an unusual business. The customers constantly upgrade their hardware, but the building keeps generating income year after year. Think of it like an apartment building. The furniture changes, the tenants may eventually change, but the property continues creating value. Except instead of families, the tenants are some of the richest companies on earth. And unlike most commercial real estate, these tenants almost never want to move. Disconnecting thousands of servers isn't like moving office desks. Entire businesses could go offline. Millions of customers could be affected. The cost of moving is so high that staying put often makes far more financial sense, which creates something investors dream about: stable demand, long contracts, predictable cash flow. But there's still one enormous threat to that business. A threat every operator fears because it can destroy millions of dollars in just a few minutes. Imagine you're about to complete an online payment. You press confirm and everything freezes. A few seconds pass, then a minute. Now imagine that happening, not just to you, but to millions of people at exactly the same time. Banks stop processing payments. Businesses lose customers, hospitals struggle to access records, factories pause production, airlines can't process reservations, stock trades fail, streaming platforms go dark. What looks like a technical problem quickly becomes an economic one. Every minute of downtime doesn't just interrupt computers, it interrupts business. That's why data centers are designed around one simple idea: failure should never reach the customer. Every important system has a backup, sometimes two, sometimes three independent power supplies, duplicate network connections, backup batteries, emergency generators, separate cooling systems, redundant control rooms. Even maintenance is carefully planned so equipment can be repaired without shutting the facility down. To an outsider, it might look excessive. To the operator, it's insurance, because reliability isn't an operating expense. It's the product being sold. Customers aren't simply paying for servers. They're paying for confidence. Confidence that when someone opens an app, makes a payment, starts a video call, or asks an AI a question, everything simply works. Every single time. For years, people believed the future of artificial intelligence would be determined by better software. Smarter algorithms, more powerful chips, faster computers, those things still matter. But today, another question has become just as important. Where will all that power come from? Every new AI model demands more computation demands more servers demand larger buildings demand more cooling demands more electricity. Eventually, every breakthrough in software arrives at the same physical limit: energy. For the first time in decades, some of the world's biggest technology companies aren't just competing for customers. They're competing for megawatts, for access to electrical grids, for construction materials, for skilled engineers, even for the right piece of land. The race for artificial intelligence has quietly become a race for infrastructure. And infrastructure can't be built overnight. A new AI model might take months to develop. A new data center can take years. Expanding an electrical grid can take even longer. That's why many of today's biggest challenges have nothing to do with writing better code. They're about solving engineering problems that most people never see. The internet isn't becoming limited by imagination. It's becoming limited by physics, and physics doesn't negotiate. At the beginning of this documentary, we asked a simple question: what does it really cost to own a data center? The answer isn't just money. Yes, the land is expensive. The buildings are expensive. The servers are expensive. But those are only the visible costs. The real investment is much larger. It's decades of planning, relationships with utility companies, massive electrical infrastructure, redundant systems that may never be used, thousands of invisible engineering decisions made long before a single customer logs in. Owning a data center isn't really about owning a building. It's about owning certainty. The certainty that millions of people can connect at exactly the moment they expect to. The certainty that businesses never stop operating. The certainty that an entire digital economy continues moving without anyone noticing the machinery behind it. That's what customers are really paying for. Not computers, not walls, not even electricity. They're paying for uninterrupted trust, and trust may be the most valuable product in the digital economy. Tonight, before you go to sleep, your photos will still be backed up. Your bank will still process transactions. Your favorite streaming service will still be ready for tomorrow. Artificial intelligence will continue answering questions. Somewhere behind concrete walls, inside buildings that look almost ordinary, millions of processors will continue working without applause, without headlines, without anyone thinking about them. The internet was never weightless. The cloud was never floating. It has always lived inside real buildings, built with steel, powered by electricity, protected by thousands of people, and funded by billions of dollars. For more than 2 decades, these places quietly powered our digital lives. Now, as artificial intelligence reshapes the world, they've become something even more important. The factories of the 21st century, invisible to almost everyone, essential to everyone. And perhaps that's the greatest irony of all. The more digital our lives become, the more they depend on physical infrastructure, not somewhere in the future. Right now, the next time you open your phone, watch a movie, transfer money, or ask an AI a question, remember, your request isn't disappearing into a cloud. It's traveling to a factory that never sleeps, a factory that costs billions to build, millions every year to operate, and exists for one purpose: to keep the modern world running, one calculation at a time. We often imagine the digital world as something invisible, But every digital revolution has required a physical foundation. The buildings we rarely notice today may one day be remembered the same way we remember railroads, power stations, and highways, not because people admired them, but because civilization quietly depended on them all along.